Good morning, AI Fringe. It's a real pleasure to see so many of you gathered here again. My name is Isabel de Pauw. I'm an Associate Director at Milltown Partners, and I have the pleasure of introducing a panel to you on a topic that I am personally really excited about, which is a panel that will be assessing the wider impacts of AI training and inference when the sort of model is being actually deployed, and especially the sort of impact on the environment as well. When I was still in government, I worked on these issues, and we had sort of a real challenge of building an understanding of the sort of sector underpinning this AI training and deployment, and sort of coming up with the right metrics to measure the impact and sort of trying to understand the sector writ large. So it's a real pleasure for me to say that this panel will be diving deep into this topic, and they will be exploring practical approaches to not only assess the impact, but only try and reduce the environmental impact of AI training. And it will be really starting out with the very foundation, which is sort of measuring and quantifying this sort of somewhat nascent industry. So please join me in welcoming this fantastic panel, which will be moderated by Dr. Natasha McCarthy from the Royal Academy of Engineering, she'll be joined by Dame Dawn Childs from Pure Data Centers, Professor Marina Jirotka from the University of Oxford, and Dr. Loïc Lannelongue from the University of Cambridge. Enjoy the session.
Brilliant. Yeah, we're all blinded here. There we go, we can see you all. Great, we're all set? Thank you. It's so great to be here. My name's Natasha McCarthy. I'm an Associate Director at the Royal Academy of Engineering, leading our programme of policy work. I'll start off by saying just a little bit about who the Royal Academy of Engineering are, because you might not have heard of them, but we are one of the UK's national academies, recognising brilliance and excellence in engineering by making people fellows. We also have major funding programmes, so we fund engineering research, including tenure chairs in emerging technologies, so that enables people to take engineering ideas from research to reality. We also support spin-outs, scale-up startups through our Enterprise Hub, which is based in London, but also across the whole of the UK. And we support people getting into engineering. We want to see a diverse group of people coming in and bringing skills to engineering. And one of the things that we also do is draw on all of that brilliant engineering knowledge to advise policymakers on the big challenges of our time. And we do that through the National Engineering Policy Centre. That is a partnership of all of the UK's professional engineering organisations, from those close to AI, such as the British Computer Society, to those that will be using it, such as the Institution of Engineering and Technology, with many people working in the energy sector. Now, I think AI and engineering are linked in many ways. I mean, fundamentally, AI depends on engineering. The infrastructure, the systems, from the chips to the data centers that make AI work are engineered systems. And what that means is that there are engineering and design choices in how we build AI and how we influence how AI works. And therefore, we need to think about how we make those choices mindfully. We also think there's quite a lot to learn from how we think about responsible engineering at the Academy, which is all about engineering that is safe, that is reliable, that is inclusive, that's sustainable. So we've been looking at the sustainability of AI recently in our policy work. So just Friday, we published the very first output from our work on engineering sustainable AI. And that called for 5 things. And these are the foundations for sustainable AI. They're the kind of necessary conditions before you can really make the changes that will make AI sustainable. So we called for the expanding of environmental reporting mandates. We talked about addressing information asymmetries across the value chain. We talked about the need to set environmental sustainability requirements for data centers. We called to reconsider the data collection, transmission, storage, and management practices. And we think there's an opportunity to lead the way through government investment. And obviously, AI sustainability was raised in many ways across the Action Summit. We're very happy to continue the conversation here. And I've got 3 brilliant speakers who will talk to this. I'll let them introduce themselves. But very briefly, it's Dame Dawn Childs, who's CEO of Pure Data Centers and a fellow of the Royal Academy of Engineering. Dr. Loïc Lannelongue, who's a senior researcher at the University of Cambridge, and Professor Marina, Jirotka, Professor of Human-Centered Computing at the University of Oxford. Brilliant to have you all. So, as I said, I'm going to give you an opportunity to say a little bit more about yourself, but when you do that, because we all know there's a big opportunity for AI to support progress towards net zero and wider sustainability goals in the UK and internationally, as you introduce yourselves, could you give us your sort of favourite or most exciting example of how AI can improve sustainability, whether it's something really transformational or really practical? I'll come to you first, Dawn.
Thank you. And so Pure Data Centres Group, we operate and build data centres for the big tech companies that you'll all know and love, so the Microsoft, Googles and Amazons of the world. And of course, within that sort of suite of data centres that we have, there are some that will be moving towards AI and large language models and machine learning. The thing that excites me most about the application of AI and the transition to net zero is the ability for it to help to work to solve the challenges with the transmission networks and grids, both in the UK and also internationally. There are significant constraints, and we've all heard the power-hungry data centres. Well, actually, those very data centres and AI can help us to solve some of the challenges of that net zero transition, because without it, quite frankly, we're not going to get there. So that's the thing that excites me most, that opportunity.
Wonderful. Thank you, Dawn. I'll come to you next, Loïc.
Thanks. Very happy to be here. So I'm a researcher at the University of Cambridge, and I work mostly around environmental impacts of computing. And so I lead this Green Algorithms initiative, building tools around this topic. Maybe the application I'm most excited about, and that's because I don't do it myself at all, is around biodiversity and rewilding. So using AI, using satellite imaging to really figure out the best way to do rewilding, the best way to support biodiversity. There are amazing opportunities there. Obviously, at the same time, I'm hoping AI doesn't, we don't have to do a lot of rewilding because a lot of the impacts of AI kind of trashed it in the first place. So that's trying to find the line. But it's a really exciting aspect.
I like that. It's a really nice example. Marina, to you.
Yes, so I'm Professor of Human-Centered Computing at Oxford. I'm also Director of the Responsible Technology Institute. And I think the thing that excites me most, certainly being an academic, is the fact that these AI issues and sustainability are so systemic that we need to all come together within disciplines and a multi-level policy, government, academics, citizens, to actually discuss and talk through what some of these challenges of making AI sustainable for people and for the planet and for the environment. And I think that because we've got that opportunity now to do that, I think it's incredibly important to do so.
Couldn't agree more. Thank you all so much. So I'll come to you next, Dawn. So to realise the kind of opportunities that you just talked about and to kind of enable those conversations, AI itself needs to be sustainable. So can you tell us about the trends that you're seeing in terms of resource use by AI currently? And in particular, can you go through what you think can be done in terms of how we design, build and manage data centres?
Yeah, absolutely. And so if I go back probably even 5 or so years, when companies like Pure were building data centres, if you had a 1 or 2 megawatt data centre, you were thinking it was quite big. As we look at AI and we look at particularly the large language models, and you've probably seen in the news over the past months that they're getting bigger, more GPUs, more compute power, more needed, apart from the DeepSeek moment. Generally, bigger is better, and the more accurate the model will be. We're now talking in the hundreds of megawatts or gigawatts for those data centres. And so I think it's really important that we set out a suite of directives, like a rule set, a minimum base of how sustainable those data centres should be. Generally, because of the cost of power, those hyperscale or mega-scale data centres are being built in places where there's a proliferation of cheap renewable energy. So that's good. So the power to power the compute is generally sustainable. However, what we're not seeing is a significant rule set around water usage, around PUE, so the power usage effectiveness, so the power that powers enables the compute to happen. So ensuring that we're doubling down on that, I think, is very important. So, from a cooling perspective, you don't need to use free-flowing water to cool the data center. You can have closed-loop systems. That should just be a rule set and a minimum baseline that's out there. We should be looking more at sustainable materials. So you can make, particularly if there's a significant amount of land, you can have a single-level large data center, and it could be timber-framed, maybe. So there's an awful lot more that could be done around sustainable materials. I also think that we've seen a trend in recent months of the power for the compute coming down as well, which is great. So the amount of compute that you can get out of a megawatt of power going in is increasing, and I think that we should see that trend continue as they work on the chips themselves and making them more efficient and more effective. So the trends are moving in the right way, but I think the rule sets need to be put in place. The European Energy Efficiency Directive drives some of those rule sets, but we don't have the same here in the UK currently. So I think there should be a minimum baseline around sustainability standards for data centres.
Great, thank you. And do you think that the example of DeepSeek shows that there are different models that maybe use a bit less energy? Do you think that's bucking the trend, or do you think that might be just a kind of particular example?
So it definitely focuses the mind. So I think that whether or not there's pure truth in the amount of output that's been had from the input that they declare, so the 5.6 million in terms of cost. I'm yet to be convinced, because I think there's probably some sort of baseline learning they took from some of the other models. However, the fact that they've been able to use far less tokens, like orders of magnitude less, and get a nearly as accurate output, I think is really important. And I think that will drive more innovation and greater thinking. I also think it democratizes the use of AI. So it means that easy-to-use AI will be in more people's hands, and that will just help to accelerate some of the initiatives, accelerate the innovation, and make people double down, force them to focus and think about this. So I think it's generally good.
Brilliant, thank you. I'm sure we'll come back to that theme. I'll come back to you now, Marina. So with the government-endorsed AI Opportunities Plan, we're seeing a significant focus on AI adoption, so the use of AI. So how might our use of AI systems and services influence the environmental impacts? And how can we balance societal benefits of using AI with its environmental footprint?
Well, I mean, the environmental impacts of AI are a particularly pressing challenge. We published a paper recently looking at the difficulties that are inherent in both measuring and mitigating the climate impacts of AI. And one of the issues we really wanted to highlight was that real challenge of measuring, because there are very different measurements and we don't actually know what we're measuring as we're going through. Or we might be measuring one specific bit and not being able to compare it with what other people are measuring. But even just looking at energy usage, we also know that some of the impacts that our AI is having in environmental terms, as you said, energy demand has been rising in data centers, proliferating. In Ireland, data centers already account for 20% of the energy consumption. Big tech companies are now some of the largest purchasers of carbon credits. So in general, I think we have to pay much more attention to what we're using these energy-intensive systems for. Phrases like cloud computing really tend to disguise the fact that these systems use phenomenal amounts of natural resources. We need to understand that cloud services have a physical impact in the world, servers that are built from finite material resources, and we need to ask ourselves if we're sure that that's what we want to use these things for. Kate Crawford's excellent book, The Atlas of AI, I don't know if you know it, mapped out the extractive nature of these systems in both human and material terms and developed it into an incredibly impressive piece of artwork which shows everything from the rare earths used in manufacture all the way to the infrastructure in our homes and the data that we supply. This kind of systems thinking approach, which I think we really need, builds on that interdisciplinary point I made earlier. In order to really assess the impacts, we need to take a holistic view, and that means drawing on multiple understandings and different areas of expertise.
Absolutely, I very much agree, and I think of that personally as part of the engineering process. I often say engineering is a social science. It's got to think about a system as something that is socio-technical, and I think that's definitely a really interesting framing. Thank you. So Loïc, we are seeing AI hype shifting, so it's machine learning and it's generative AI and agentic AI, with some dispute whether that's a new thing or not. How does the type of AI model that we develop and use change their environmental impacts, and how can we measure that? So picking up some of the themes we've heard already.
Yeah, I'm so glad you mentioned The Atlas of AI. It's a brilliant book, worth reading just for the pictures, really. They're amazing. So, I mean, like one concrete application of that, we had the first sustainability report coming out of like big tech companies last summer since ChatGPT and everything came out, and Microsoft reported something like 30% increase in carbon footprint over the past 3 years, Google 50% over the past 4 years, 5 years. And these are enormous numbers considering they were on quite stark net zero trajectory. So they were kind of aiming for net zero, and basically they said, oh, it's all because of AI, and we're not going to do net zero anymore, like the targets are blown out of the way. And so that's kind of an example of how generative AI gets in the way. The first question is usually, do we really need them? Because there's very little applications for which we need a general purpose model, except if you want to put a flag in the ground and do something like what OpenAI did with ChatGPT, then suddenly everyone only thinks of ChatGPT as a generative model. But actually you could have different models doing all of the small subtasks for which it does it. And there are some interesting work showing that actually if you break down a general purpose model into a lot of task-specific models, well, first, they're probably going to work better at every single task, but also the combined energy usage will be a lot lower than the general purpose. So actually, there's a lot of energy wasted by just trying to make one model work for everyone rather than having task-specific ones. In terms of generative AI agentic models, it's like the balance between training and inference starts to shift, because historically, like back in the days, like 10 years ago, we would train a model once, and then we would make predictions on the whole data set, and that would be your inference phase, and then you would be mostly done with it for a while. Now with chatbots or agentic AIs and things like that, every time you query it, you get new inference. And I mean, the estimates vary greatly. It goes from like 30 to 80% of the total energy usage goes to inference alone versus training. So that's the question is, how long do you need, like how long until inference makes up for the training? And something like ChatGPT, actually within a few weeks, inference is the main driver of environmental impact. Small models, it will take a lot longer. So that's the main problem. In terms of actual environmental impact, I mean, as mentioned just now about the Atlas of AI book, they are kind of the same. You use electricity, you use water, even as you said, we don't really need to, but actually a lot of them still do. You extract resources from the ground, and that's just kind of directly environmental impact. It doesn't take into account people and displacement and so on. But the impacts are the same, it's just the scale gets a lot bigger because the use base gets a lot bigger. We used to say, you've probably all seen, the number is probably completely wrong, that you've seen ChatGPT is probably 10 times worse than Google. This 10 comes from nowhere. I mean, like there's no idea because OpenAI is really good at hiding their tracks. But it's kind of obvious that the energy usage would be a lot bigger for something like ChatGPT than a simple Google search. Except now, I don't know if you've tried to do a Google search, and if you phrase your Google search question as a question, like how do I blah, 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 actually what you get first is a prompt by Gemini saying, basically it's the same thing as a Google ChatGPT prompt, which is the Google chatbot. So now you can't even get away from not using these models, and that's where a lot of the environmental impacts come from, because suddenly it becomes like put everywhere.
Absolutely, that's really interesting because you've pointed out, firstly, you don't have to be locked into one model. There's different ways of doing things. But then if you find you're using a model you hadn't consciously chosen because it's built into another system, so that kind of takes a bit of control away from the user, doesn't it? It's a really interesting point. Now, Loïc just sort of started to bring this up, Dawn, but it's not just about kind of sustainable operations. We need to be striving for environmental sustainability across the whole AI lifecycle and value chain. And this is, as we've said, made of stuff. And Loïc mentioned the point about extraction of the materials for AI, but also what should we be doing to minimize end-of-life impacts when this material becomes rapidly obsolete? How do we keep that sustainable?
And so I think there's a few points to consider. So if I think about data centers and for anybody that doesn't realise, to pick up on some of the previous points, data centers are effectively the physical manifestation of the cloud. So every time you do a search or you store data, they're routed through or stored within the data centers. So the compute power that's inside the data center has a shelf life. And at the moment, that gets changed out pretty quickly. So every few years that's changed out. But I have seen a recent trend, mainly linked to the lack of availability of the chips originally, where all of a sudden the compute racks, the servers were being life extended. So rather than seeing a life cycle of, every few years them being changed through, they were starting to use them for longer. I think that should be the baseline going forward. There should be a minimum expectation of life, and then also a reuse of all of the critical materials that are within those servers. And already the big tech companies try to do that, but as DeepSeek has shown, there's so much you can do with not the most super high-tech, most recent version of a GPU or any other chip. So actually there is a re-life in these components that should be considered far more. And we did see when there was a significant reduction in chip availability, some chips being taken out and being reused and repurposed. So they were rebuilding servers, and again, I think they should consider that far more in big tech. So yes, there's a place for new innovation and new technologies, of course there is, and there'd be a reduction in the amount of power for the amount of compute that you could get from those, but also there's a purpose to older components. So that should be a minimum baseline. I also think that there's something around the capability of different fraternities to make use of some of those components. So just because it's no longer suitable for the big tech companies doesn't mean that it doesn't have a life elsewhere. So think, as many businesses currently do, they give their laptops to schools, for example, who maybe don't need the most up-to-date, fastest components. So I think everything should be considered from that perspective. I also think that there's a good calculation to be done around the reuse of the very buildings, because some can be repurposed very easily, others need to be recycled in a more sustainable way. So it might be better to actually build down and knock down and start again and reuse the components for something else. But we don't tend to come from that starting point at the moment, so I think we should.
Thank you. Loads of considerations there. And there's also the end of life of the data itself as well. We're not always the best at kind of managing data and not storing obsolete data.
Well, yeah, and it's funny, I've had this debate before because I had a thesis that we ought to have like a data deletion act where, think of like a reply all thanks email. It shouldn't exist, right? But I had a very interesting debate with I think it was probably one of your colleagues a while back, where the amount of humanly generated data that's now available, we're at the tipping point where the large language models have pretty much used and learned all of the human generated data, and there's now potentially more computer generated data out there on the internet than there is human generated data. So actually those reply all thanks emails and cat videos, which I hate and think ought to be deleted and not stored, have a purpose because they're human generated, so it tells the machine something about us. So I think actually if we double down on sustainability and efficiency, there probably is a place for this human-generated data that I was busy trying to get rid of.
That's really interesting. I like that. So back to you, Loïc. So we know it's difficult to define proportionate interventions when the scale of the problem isn't well understood, and we've come to this a little bit. So our report recommends mandatory sustainability reporting, so that AI is in line with other industries that have to report how much energy they use. How important do you think is that data on energy and other resource uses? And how can we enable it to be accurate and trustworthy?
Well, I think it's absolutely crucial. But so we know how to do it. If you take the example of clinical ethics, for example, we don't know everything. When you start a clinical trial, you don't really know what the outcome is going to be, and you don't really understand what the side effects are going to be. But you still have to sit down and write a statement saying, well, these are the possible downside of what I'm going to be doing, and this is a reasonable case about why I think the potential benefits will outweigh the cost. So we could apply the same logic to environmental impact. It hasn't stopped medical research, so I don't see why suddenly we'll stop AI research all of a sudden. We do it when we apply for grants. We say, well, we don't really know what we're going to find, but we think it's worth that much money. So we could say it's worth that many tons of CO2 if we just we wanted to simplify it. One way to get the data, well, this effort just announced yesterday, actually, at the Forum for Sustainable AI in Paris. There was the Coalition for Sustainable AI, which I think the Academy has joined, actually, which is quite a large-scale adventure, really. So I think there's over 100 companies joining. Some states, the UK has joined actually, France as well. And one of the goals is to try to standardize how we assess the environmental impact of AI, not only, but that's one of the goals. And I think that's going to be interesting because we have enough knowledge out there to be able to do it reasonably well. We need more data, we need a lot more, but actually we have enough to make very educated guess. And there's no reason why we don't, except if we all start doing it differently, and that's what I mentioned before about, for example, PUE or things like that. Standardizing is quite important. One way to estimate these impacts is, well, you either do it before you start a project, right? And that's what I was mentioning before a little bit. Or you do it afterwards. And the reporting afterwards, that's where you really need to have companies on board, because a lot of the information, it's available in data centers, a lot of things, how what water usage is used. You mentioned that. And the information is out there. And for public relation reasons, I understand why it can't always be put out there by all the actors and all the big tech companies. But it could be there if people say, well, we're going to be transparent about all our impacts. So then people can actually make a choice. And we go back to people-centric. People can make a decision to say, well, we're going to use this slightly more expensive cloud provider or data center, but because we want to have sustainability guarantees. And I think, especially in AI, where so much is driven by research or machine learning engineers or software engineers, but building the models, they have a lot of control about what models they build. It's a fine line. We want to put some responsibility on people, and that's actually really what we've been doing with this Green Algorithm Initiative from the start, was to say there's been amazing effort in improving data center infrastructure and efficiency, and as I'm sure you know, and that's been going on for a long time, except people building the models thought, well, that's not my job. People in data centers, that's their responsibility to make the data center efficient. I run whatever I want, that's not my fault. And so we've worked on building tools and resources to actually bring that responsibility a little bit back to people. We don't want to put all the burden on end users, because that's not fair either. But there is some responsibility when you're building an AI model to say, do I need to use the biggest model here, or actually a small model will do the job just fine? And so if we provide the data, and to your point about trustworthiness of data, we need providers, infrastructure to be transparent about their data, so then people can make educated guess. And that's really essential. Just on the point of the importance of data, I recently did a report for the Department for Science here around the environmental impact of the UK digital sector, so very broad, very high level. So you have user devices, you have networks infrastructure, and you've got data centers. User devices is easy, you know how many things are being sold, that's the easy one. Network infrastructure, you have to rely entirely on network providers because they are the only ones who know what they built, and that's a bit hit and miss. The hardest one was data center. Because there's no aggregated statistics about how many data centers we have in the UK, who is operating them. And some actors, the problem is you end up with the good actors doing good just because they know they can, but then the people who don't care because they don't have to, then they will not. So it's a bit mad that nowadays we don't know how much energy is being used by data centers in the UK. Like Ireland, they know just because it hit such a ridiculous level that they had to look into it to be like, we have a little bit of a problem now. So I think that would be a very important first step, to get this trustworthy data, so then that can inform policy, but that can also inform user behavior, so we can have both top-down and bottom-up.
Absolutely, and inform the design of tools to help increase sustainability overall.
Yeah.
Very good point, thank you. And now to you, Marina. If we make efficiency improvements in how we design and develop AI, such as the infrastructure, the compute, the code, as we've talked about, do you think that's enough to guarantee the long-term sustainability of AI?
That's very interesting, because if you take a systems thinking approach, we understand really that sustainability isn't solely about efficiency or energy use. It's also important to look at the way the chips are manufactured or end of life, the way rare earths are used in them, the infrastructure that's going into these systems. And historically, efficiency has counterintuitively actually meant that we end up using more of whatever it is. And this is known, as I'm sure you know, as the Jevons paradox, from the observation by Jevons actually in 1865, that increasing efficiency in UK's coal usage actually led to much more and increases in demand. And we see this with technology. The growing demand for digital technology has meant emissions from ICT industry over the last 50 years has risen from almost zero to the current levels, despite rapid improvements in efficiency. So focusing on efficiency only fails to recognise the broader impacts of these efficiencies, which is actually, instead of giving us some headroom to think through what these things are, it makes us much more likely to use more of that resource. So given all of that, it's very difficult to make any sorts of guarantees. As with all ICT systems, we need to use efficiencies in the AI space to give ourselves headroom, not an opportunity to extend that use even further. And the key to sustainability is really to accept that we're going to need to work within limits. There have to be limits. We live in a finite planet of resources. We need really to recognise that ICT in general and AI in particular does have those environmental impacts and build into our assessments of whether and how much we actually use it. We have to understand and accept constraints on these and to use those constraints as a spur for creativity, not just lengthen and keep using in the same way.
Brilliant, thank you. And do you think it's a challenge that the kind of, everyday user, if you like, doesn't have a sense of how much power is generated by, a search, a query to ChatGPT, a prompt? Do you think that is a challenge, and do you think there's any way of making that visible and tangible to an ordinary user of these technologies?
I think we can do that. I mean, again, these things are behavioural, they're economic, they're political. There's all these kind of panoply of issues that we have to tackle in a systems view. I think people would be very capable. There are people who are making decisions now based on the measurements that we have for climate, whether or not you buy a particular T-shirt that's been washed 1 million times, or people are making those decisions, and that's why the transparency and the sort of the trustworthiness of that data is so important, because we have to convince people that they need behavioural changes as well.
Great, thank you. Right, so those are my questions, and I want to now move to the audience. So this is an opportunity for you to raise questions for the panel, and yes, I can see you if I just shield my eyes slightly. Oh, yes. So any questions? At the back there.
Hi there. I think, Loïc, you talked about at the very beginning that you were excited about AI's role in rewilding and biodiversity. Can you just unpack that a bit and explain that, please?
Oh dear. So that's really not the area I work in, and that's probably, but I know there's really good work in that. Some of the exciting applications are things like using satellite imaging to track deforestation. For example, things like carbon offsetting credits we know don't really work, get used massively. One of the good use of AI is to actually track deforestation, and you can do that automatically with satellite imaging, which is obviously a lot harder to do by hand. Where to plant, where to support biodiversity. There's some recent work showing that that's the best way to fight climate change. In terms of benefit for the planet, is really to support biodiversity more than just planting a lot of trees, for example. And how to do that in the best way, I think there are lots of cool application. That I don't do that days in and day out. It was around sustainability. Otherwise, medicine, lots of cool applications, but yeah, I'll leave it there. I'll let the expert talk about that.
Thank you.
Any further questions there in the middle? Mic there, great.
Hi, thanks for the talk. So one of the points was about the amount of data we have. One of the things with LLMs now is it's so easy to make more data. What impact do you think that has on resource usage? Because it's so easy to create things now. It's going to grow exponentially, I assume.
Shall I pick that up?
Yes.
So you're right. It is a little bit like it's a terrible term, a self-licking lollipop. So if you're using AI, it's automatically creating more data. You do a ChatGPT query, all of a sudden there's a whole bunch more data that's then there on the internet forever. So yes, there is a proliferation of data and exponential increase with it. But I think the important point to focus on is that if we build sustainable data centres, we should be able to support and better understand how we can limit that data and choose and select what of the machine-generated, particularly data, is kept and what is discarded. And I think some of the regulatory landscape and policy landscape should be able to help us through that thinking. Because at the moment, you're right, everything that's created is retained. And I think the point that I made around the human-generated data versus machine-generated data is really important, because you're very easily going to overwhelm all of the human-generated data with computer-generated data pretty quickly because of the proliferation through these large language models. So yeah, so I think we need to be focused on it, but I think there needs to be some regulation, and probably in the sort of the safety of the internet space, where we think about what we want to do with all of the computer-generated data.
Thank you. Loïc, Marina, any comments on this question?
Just briefly, on if we talk more about researchers more than kind of general public, we're terrible at deleting data, right? We hate doing that, which kind of makes sense to some extent, but at the same time, you end up in an absurd situation where half of the university infrastructure is just overwhelmed by data. No one knows what it is. The postdoc that generated it left 2 years ago. It's never going to get looked at again. And in terms of regulation or like more policy, like funders policy, you have to keep the data, and that's right. But there is difference between the raw data generated from an experiment, incredibly valuable. Of course, you don't want to delete that. And the million of intermediary files and all the different models you tried and everything. And it's fine to keep that for a time, but at some point it's just getting into the habit and the mindset of actually deleting data and just saying that's okay to delete things that are never going to get looked at or can't even be used. And if really someone queried my results in 10 years' time, they can just redo the analysis from the raw data. And so more generally, I think it applies to everyone, like researchers, but also and general public. But it's okay to delete some data. We don't need to keep every cat video.
Absolutely.
Back to my auto-deletion rule.
Yeah, I like this. I had a question, actually, perhaps for you, Marina. In terms of thinking about the kind of use cases and the amount of energy used in the inference mode when you're using AI, do you think there are any basis for kind of more democratic or sort of publicly led conversations about what is beneficial use of AI versus what might be seen as more profligate?
Yeah, definitely. I mean, we have been starting to do citizen juries and use juries on these things, and it's incredibly interesting when you start to hear people's views and their fears and their desires for this kind of approach, and particularly for skills. And we're thinking about what's recently happened with copyright and artists and all of that. I mean, people should have a voice in this and should have a decision about how these things are used. And currently they don't. It's driven by industry particularly. And I think we need to all come together, as I said at the beginning, to find some, either through institutes or through policymakers themselves, to start to work with multi-levels about what the impacts of these things are and how we create what we want to see in the future, and to protect our planet as well. It's not a bad thing to want to protect our environment and our planet, although currently it's not the flavour of the month.
Thank you. Yeah, we've also been carrying out some public conversations around AI, having conversations between innovators and local communities. And I remember at one of those, somebody who worked in the agricultural sector, a farmer, saying, there are constraints on how much water energy I can use, and was really surprised to see this not applying in the AI sector. So
I think there will be trade-offs. We will have to look at the benefits of the AI and think about societally, do we want that, and how do we measure what the downsides might be in terms of the environmental impact with what it might give us in the future. So that kind of thing we will have to start thinking about much more.
Yeah, absolutely. Further questions from the audience? Anybody else? There we go. We've got one right in the middle there and one just behind, about 4 rows back.
Thank you. I think what I was really interested to hear about your views on clinical trial and comparing it to this situation. We seem to be in a race to try to be more efficient and use AI just to keep up with everything. So I'm wondering how do we tackle that need for a shift towards a more reasonable and reasoned use of AI and understanding the consequences and using AI not because we can, but because we need or we should, And who's responsible for this? Is it regulators? Is it businesses? Is it academia or society? What can we do, and who's responsible for it?
Yeah. Let's take that. Who wants to go first?
Okay.
Marina.
I mean, this question of responsibility is a very interesting one because it is a multi-level one here. I mean, we've all been saying, for example, industry and the tech people need to have more transparency and more accountability. Researchers need to have, we don't want to be in that kind of race. Researchers need to come together across disciplines in an interdisciplinary way to understand the nuances of some of these things, you know, like the rebound effect, like the effect that efficiency creates more use rather than less, and so we have to have some kind of constraints. And government need to be able to understand these things. So we as researchers need to be able to tell government and policy in ways in which they understand better what the consequences of some of these things might be. But again, systemically, this is a global thing, because we in the UK can decide to do one thing, but then perhaps we're not taking seriously the carbon footprint of our imports. And so we need to have a much more global understanding of how we deal with these things, I think. And that's why it's multi-level and very complicated.
I think in the EU, they've already got some policy or legislation facing particularly data centres, which is more about measuring and ensuring that the sustainability footprint or credentials of each data centre is known and understood, because there's a reporting requirement now around energy use, water use, etc. Overall, carbon footprint. We don't yet have that in the UK, and I think that's really important to get that sort of understanding in place. The recent designation of data centres as critical national infrastructure will help a bit in that, because there's some regulation wrapped around that. So if you have a large-scale data centre and it comes under the critical national infrastructure scheme, then they need to know about it and understand it. So we'll have a much better understanding of where particularly the larger scale data centres are, but not yet the measurement in terms of their sustainability, power and water consumption. So I think there's a measuring element to then enable us to analyse. I also think that there's a requirement to ensure that as the sort of AI race is being run, we are slightly more measured in our approach, because currently my sort of concern is that we're building out a significant amount of infrastructure, some of which won't be required, because all of the big tech companies are running to win this race, and they can't all win it. So having an understanding of the actual requirements versus their desire to monopolise the usage of the requirements, I think might be an important point for particularly global governments to take a view on. There's a dash for sovereign capabilities, but do we all really need to be able to do that, or is there more collaboration that's needed? I mean, it's geopolitically very sensitive, I know, but I do think that there's quite an important point in there.
Did you want to come in? No.
Yeah, well, I like the idea. I mean, this idea of winning the AI race, when you think of it, is like, it's a bit crazy, because no one has said, oh, we're going to win the genetic race. You're just trying to have like groundbreaking project in one particular area, and you said, oh, we did that great, but that other country did something great. So, and the problem of that is the only way people can see to win the AI race is to do this general purpose model and say we will do an AI that can do everything, and that's going to mean winning the race, which is obviously completely inefficient in terms of, as you said, you need large data centers to do. Instead of just saying we're going to have the best medically assisted radiography tool, for example, and that's a very specific tool. Anyway, but that's really interesting. On the incentives things, I don't know. So I was at the Forum for Sustainable AI yesterday in Paris, and there was a head of sustainability at NVIDIA and head of sustainability from Google. Having heard them speak, I will say definitely regulation will be needed. Because that's not only saying, oh, we have great applications, because they do. It's just completely ignoring environmental impact. Like I haven't heard them say once there is an environmental impact of AI and data centers, which is not controversial, right? It's not a judgment of whether it's worth doing. It's just a fact. It uses water, it uses electricity. There's just, once again, people who want to industry actors who want to care, and the other ones don't. So there will need to be some regulation. An interesting example came out from the French Department for the Environment, actually. They have large-scale funding because everything is very centralized in France. And they had one project, something like 20 million, to fund AI to support local communities for sustainability. So things like optimize the energy grid of nighttime lighting in your town, or make the pool heating more efficient, this kind of very specific application. They required that in all their applications, they have to include an environmental impact statement. So they have to estimate the carbon footprint of the AI solution they propose, at least have a ballpark estimate, and they have to explain why they think it's a reasonable use of that much carbon. And so we worked with them because they used our calculator for that. And that was really interesting because it worked so well, actually, because it was a clear application that they now expanded it to all their AI and climate funding calls. And that's an example of putting the incentives, saying, like, we're not saying you can't use carbon, we're just saying, like, we should be able to sit down and make a reasonable case about why our project is worth it. Now, obviously, it's a lot of assumptions and a lot of uncertainty, but if we can't even do that step of sitting down and writing half a page about why it's a reasonable use of whatever the environmental impacts are, probably it's not, we shouldn't do it at all. So that's an example of like how we can play on incentives and, slightly differently.
Great, thank you all. And then the next question, I think you've got the mic there now.
Hi. This is a question for Dame Childs. You started by saying you were excited for how the demand for energy could drive the green transition and change grid connections. And we're seeing in the US, like Microsoft is buying or recommissioning 3 Mile Island. In the UK, we're seeing small modular reactors starting to come in. How do we end up? Sorry. At what point do we think that the energy infrastructure is going to belong to us, for example, rather than belong to necessarily these corporations who might end up not needing it? Yeah, sorry, that was not very clear, but...
It's okay, I think I can probably come up with some points to play into that. So I think there's a couple of aspects in terms of how data centers in particular, so AI in general, but data centers in particular, can help us with the green transition. For a start off, every single data center has to run at a reliability level of what's called 5 nines, so 99.999%. So if you're running a data center for a big tech company, that is the reliability they expect. And to enable that reliability, you have to have 100% backup power. So for every 10 megawatts that I get off of a grid anywhere in the world, depending on where my data center is, I have generators, so HVO fueled, so green fueled generators, ready to instantaneously cut in if the grid cuts out. So whilst we're looking at renewables coming onto the grid and every single grid globally trying to transition to green power, that there's a challenge in taking large generators. So think about, we just closed down our only coal-fired power station. There are still lots of gas power stations in the UK, and you'd need quite a big chunk of new renewable generation and also powered base load, so think nuclear or something more smooth on a grid, to be able to then turn off a big gas generator. Well, I think all of this standby power that's already available, you heard 20% of Dublin's power goes to data centres. That means there's 20% standby generation just sat there waiting to be used to help with peak lopping. So I think that use could really help data centres, so AI, to be at the middle of the green transition. I also think that demand response is in there as well, and AI can really help with the demand response. So how, at the moment, on any grid globally, if you've got renewables, they can only be used at the point that renewables are available, so sun is shining, wind is blowing. They often get turned off because that's too noisy, that amount of power is too noisy in the grid, and they prefer smoother power, so like gas generation. So the moment in the UK, a wind operator will be paid to turn their generators off, and a gas generator will be used in preference. Those are big chunks of power at the moment. if you had this ability to do demand response better by using AI analysis, you could then make use of the standby power. So I think there's quite a lot that the large energy users like data centers can do, or even industries can do, to help with the green transition that hasn't really been properly thought through yet. Developing SMRs and having great off-grid power generation could be part of that, if it's then dynamically connected into the grid, and as I say, you have this demand response profile over the top. So it's exciting space. It's not been properly explored yet, but I think it really could be a step forward.
Thank you. I'm just about to come to the panel now for their last words. I just want to ask everyone here a question. Is there anyone in the audience who's ever thought, I'm not going to run this bit of AI, I'm not going to do this generated email response, or I'm not going to do this query because it's an unnecessary use of energy? Has anyone ever made that decision? Oh, I like it. We've got some people engaging on this. This is brilliant, and that's what we need to see. That's fantastic. So I'll come to you in order from me. Just your last thoughts on what you think will have the biggest impact in reducing the environmental impacts of AI. Dawn, you first.
So I think making sure that big tech and particularly data centers are built thoughtfully, ensuring that we understand the future potential demand profile. We lean into aiding the green transition in multiple countries, and take away. So absolutely, the end user should be able to responsibly make a choice. But I think it's up to big tech and companies like Pure to help to solve that, so that the choices are easier for the end user. It shouldn't be up to the end user to decide to use or not use AI. It should be up to us to make it sustainable.
Brilliant. I like that. Marina?
I completely agree with that. I would also add, and as a call to researchers really, as a call globally to researchers, that we need to understand a very under-researched area of rebound effects, indirect consequences of what happens when we focus just on one thing like efficiency. We need to understand those nuances and what the impacts would be in responsible innovation. It might be even something like anticipatory governance. So you're trying to think what some of the unintended consequences of where we're going or what we're focusing on will be. So I would like to see much more research done onto rebound effects and indirect and direct consequences.
Thank you. And Loïc?
That's really hard to be the last one on that one. No, completely agree with all of that. I'd say it's aligning the incentive. So it's saying you can't build an AI model if you can't explain to me why it's worth building and why it's in the best interest of the climate crisis. Because really, it doesn't matter if it finds unlimited renewable energy in 200 years. Like, we don't have that kind of time. So I think putting more restrictions on that, or at least it doesn't have to be purely regulatory. It can be around, user-based, or it can be around the change of values on how we consider AI. But just submitting it to the same kind of model that we submit everything else, like cars. We don't release a car and say, let's wait until it crashes and then we're going to fix the problem. You have to test it first and explain why it's safe first.
Great. Thank you all so much. I'm so grateful to have a great panel of people bringing a wide range of insights to this. We've heard there's lots of opportunity to shift in how we design, build, and use all of the kind of systems that enable AI to ensure that it's more sustainable. I think there's going to be a need for conversations between researchers, academia, industry, governments to really make this a reality. And in the meantime, I encourage you all to take a look at our National Engineering Policy Centre report on Foundations for Sustainable AI. We'll have some hard copies outside to take away. But just want to say thank you so much to our panel.
Thank you.